right, everybody, so this is 3.1D. We're going to start looking at tiles that are other than positive and negative 1. So if you were sitting in class, this would represent positive 1. This would represent negative 1, just like shown here. And then this bar is represented as an X, and that this flipped over to the red side would be represented as a negative X. Okay, so that's what we're looking at if we were dealing with these in class. Using your pencil, we're going to shade in negatives and keep open or empty the positives. Okay, all right, so it says write an expression for what you see. Now this can be a little tedious. What I see is -1 plus -1 plus -1 plus -1 plus -1 plus 1 plus 1 plus 1 plus 1. Okay, that's what I see. Okay, and then thinking back to our 0 pairs, my answer is -1. Okay, on this guy, what I see is x plus -x plus x plus 1 plus 1 plus 1 plus 1. Okay, in 0 pairs, you handle an x and a negative x the same way. These cancel each other out just as these canceled each other out on the last couple lessons. Okay. All right, so those cancel each other out. We're left with 1x and 4 positive tiles. Okay, this guy, what I see? -x plus -x plus x plus x plus x plus -1 plus -1. Okay, now let's think about 0 pairs. Gone, gone. So I'm left with x plus a -2. All right, number 4. Number 4, I see -x plus -x plus -x plus -x plus 1, 2, 3, 4. I had 4 of those, and I've got 2 of those. 0 pairs right there, and I'm left with 2 negative x's. All right, what's shown here? Got a -x plus a -x plus an x plus a -1 plus a -1. Okay, 0 pairs here would be those 2. I'm left with a -x plus a -2. In the last one here, I see a -1 plus a -1 plus a -1 plus a 1 plus a 1 plus a -x plus a -x plus an x plus an x plus an x. All right, now this one's a little tricky. I'm going to cross off this one with this one. I'm going to cross off this one with this one. I'm going to cross off this one and this one with this one and this one. Okay, so after handling those 0 pairs, I've got an x left and a -1 left. All right, so that's that kind of problem. Next up, use the algebra tile key from the previous page to model each expression on your desk. Sketch a picture in the space below. All right, so if we were sitting in class, we would have these tiles out, okay? And we would have an X tile and 6 positive 1 tiles. Okay, it doesn't matter how you arrange that. Okay, and it's very important to understand you can never add this bar with these tiles. Let me show you what happens here. Okay, so these do not equal. Okay, take a look at this. That bar does not equal anything to do with those little unit tiles. Do not be thinking 5.5. That is not how they work. X's stay with X's. Unit tiles stay with unit tiles. You cannot mix them together. Okay. All right. 3 negative X's. And 2 negative units. Okay, remember I am sticking with shaded in means negative, not shaded in means positive. Okay, all right, this guy, 4x tiles, 1, 2, 3, 4, and 1 negative tile. Okay, and it's really important, you guys, to make sure that if you're using squares as your units, that these X tiles look larger than the unit tiles look. Okay, and if you want to go in and write down X inside there so it's clear, that's another way you could do it. Okay, all right, is there more than one way to model each of the expressions above? Okay, justify. This is key. Okay, I could add an unlimited number of 0 pairs. So meaning that could be added. Isn't this nothing? This comes out to be nothing. They cancel each other out. Or couldn't I also do what we've talked about before? An unlimited amount of these. This is nothing. Okay. All right, so for number 10 through 15, on the left, underneath each expression, model the expression and write the simplified answer. On the right, underneath each expression, simplify the expression using the commutative and associative properties. All right, so I've got 2 x's. I've got a 1. Whoops, that was a negative 1, sorry. I've got a 1, and then I've got another x. Okay, so this would give me 3x plus 1 as an answer. Okay, now showing the work over here, I'm just going to recopy this. Okay, do you remember what we did in proofs? Sorry, let me scooch that up. Do you remember what we did in those little proofs last time? Okay, we're going to commute either these or these. Okay, I'm going to go ahead and commute. And then I'm going to go ahead and group. And then I'm going to go ahead and substitute. And I get the same answer as I got using tiles. All right, this guy, 3 x's. 3, 1, 2, 3, 1, 2, 3, 4, 1, 2. All right, let's take care of 0 pairs. So my answer is 3x plus 2. Okay, now doing this one mathematically, step by step, using our properties that we learned the other day. Okay, I'm gonna go in and I'm gonna group the 4 and the -2. They're already next to each other. So I just went and put parentheses. I grouped them, I associated them. And then 4 plus -2 gets me that same answer, 3x plus 2. Okay, a few more of these. All right, 2x, 2x, another x, 2 negatives, 3 positives. Okay, let's do some 0 pairs and see what's left. 3x plus 1 is my answer. Okay, let's go ahead and rewrite this problem. Okay, I'm going to go in and I'm going to group together the x's and I'm going to group together the numbers. That's called the associative property. That's what I use to be able to group them. Okay, now these two can be combined because they both have x's in them. And then these two can be combined because they're just integers, they're just numbers. Okay, so 1. Notice I should have the same answer with tiles, without tiles. Okay, this guy, 3 negatives, x's, 3 negative x's, a positive 1, and another negative x. All right, I don't have any 0 pairs on this problem. What I do have are 4 negative x tiles and a positive 1 tile. Okay, on this guy, I'm going to go ahead and recopy the problem. I'm going to commute. I commuted the 1 and the negative x so that my x's are next to each other so that on the next step, I can group. And then a negative 3 x's and a negative x. If I had 3 negative x's and another negative x, wouldn't I have 4 negative x's? Same answer as I got here using the tiles. Okay, 2 more. So I've got 2 x's, positives, 3 negatives, units, and then 2 negative x tiles. All right, well, these 2 go away with these 2. And I'm just left with 3 negative tiles. Okay, I'm going to recopy this problem. I'm going to commute these 2. So 2x plus negative 2x plus negative 3. And then I'm going to group together these x terms. These go away. They're 0 pairs. So I'm just left with that negative 3. Okay, last one. I got a negative x. I've got 3 units. And I've got 4 x tiles. This one and this one go away. They're 0 pairs. And I've got 3 x's and 3 units left over. Okay, now solving this step by step using our properties. I'm recopying the problem. I'm going to commute these 2. I'm going to group those 2 like terms. And if I have a negative x plus a 4x, I've got 3x plus 3. All right. That concludes 3.1D, guys. See you later.